Hello, beautiful people. Welcome to today's lecture. So we are going to go through this question today. We are going to attempt to determine the solution, the general solution rather, of this given equation. So we are going to apply our knowledge of trigonometric functions and also our knowledge of being able to solve for x in order for us to find the general solution here. So I advise you to pay attention because this question is a very key question actually. So this question is worth 8 marks. So let's jump and get to business. So in attempting this question, so firstly we'll have to break down what cos 2a is. So cos 2a, cos 2a is equal to cos a plus a, right? And this is also equal to cos squared of a minus cos, this is s, cos squared of a. Sorry, this cannot be cos squared of a, this has to be sine. Yeah, it's cosine squared of a minus the sine squared of a. So this is how it should look like, right? So if we look at this equation here, this is very key in guiding us in terms of what we want to end up having, because you can see that this is sine squared of a and this is sine of a. So we would like to change everything to be in terms of sine a so that we can be able to solve for a, because our general solution will be in terms of a. So in order for us to get everything in terms of sine of a, we will need to invoke our understanding of the Pythagorean identity. So the Pythagorean is what we call the Pythagorean identity. So the Pythagorean identity for trigonometric functions is given by the cosine square of a plus the sine. Seems like I'm writing fast today. I keep making mistakes. Sorry about that. Left hand. So this is the cosine of a squared plus the sine squared of a. This is equal to 1. So this is the Pythagorean identity. So using this, we can see that cosine squared of a, the cosine squared of a is equal to 1 minus the sine squared of a. So this is what we have. So now moving back to the equation that we have, sorry, I was just adjusting my chair. So Moving back to the equation that we have, if I can just change back my pen to the black pen, I just want us to continue from here. So we are going to continue now solving the equation. So we are going to substitute our cos 2a with what we now have. We know that cosine of 2a is equal to this, and also the cosine squared of a is equal to this. So now what we are going to do then is we are going to replace cos 2a with 1 minus the sine squared of a minus sine squared of a. And we're going to have plus 4 sine squared of a minus 5 sine a plus 1. This is equal to 0. So to simplify this, this is just 1 minus 2 sine squared of a plus 4 sine squared of a minus 5 sine of a plus 1, which is equal to 0. So we continue from here. You will notice that this actually reduces to 1 minus, no, it's going to be a plus actually. It's going to be because we are adding this 10 and this 10. So we're going to have 2 sine squared of a minus 5 sine, let's say, my 5 and the sine seem to be the same. They look the same. So this is an S sine of a plus 1, which is equal to 0. It's equal to 0. So now what we left with, we are left with 2 sine square of a minus 5 sine of a plus 1 plus 1 is 2. So we're going to have 2 here. All this equal to 0. So when you get here, I know for some people it might not be as obvious, but if you look at this carefully, you will notice that this is actually a quadratic equation in terms of sine A. So if you can just make this to look better for you by doing this, maybe let me use another color. If you can substitute x wherever you see sine, sorry, wherever you see sine of a, if you substitute with x, you will realize that what you will have here is you will have, let me take back my black pen again. So you will have 2 x squared, because you are replacing your sine A with x, right? We are just doing this so that you can be able to follow. If you're struggling to follow, then this is going to be 5x plus 2 equal to 0. So now we can just apply factorization. We can just factorize this quadratic equation. So to factorize it, you can just put a 2x here, and then you can have an x here, and then this is positive 2. Our c for this quadratic equation is positive 2, which means that whatever factors of 2 we get, they have to give us positive 2. So those factors are definitely going to be 2 and 1. So for us to decide whether these factors are negative or positive, we will be guided by this middle term here, this minus 5x. So since this is minus 5x, for us to get minus 5x, we will need to have this as a negative and this as a negative, because if you multiply the 2x by this minus 2, you will have minus 4x, and if you multiply minus 1 and x, you will get and sum it up with the minus 4x, you will get minus 5x. And if you multiply minus 1 and minus 2, you still get your plus 2. When you are at this stage, normally if you are just solving for x, you just say this 2x minus 1 would be equal to 0, or the x minus 2 would be equal to 0, and then you can then reduce this to get to the point where you say x is equal to 1 over 2, or x is equal to 2. But you need to remember what it is that we are trying to find in this question. We are trying to determine the general solution for this top equation. So when you get here, it is important to realize that our x actually represents what? It represents the sine of A. So it means if we are saying x is equal to half, then it means that our sine of A is actually equal to half. Or our sine of A is equal to 2. But just before I even continue here, it's very important to um, realize that sine of A can never be equal to 2, because the mother graph of sine A is given by, I think I have this graph somewhere. Let me just go up. I had this graph. So yes, this is the graph. So this graph here is the graph of sine A. If you like, you can just call it the graph of sine A. But yeah, this represents the graph of sine A. So in this case, we can just say it's y equal to sine A. So the graph of sine A alternates between the y values of 1 and minus 1, meaning that sine of A can not be equal to 2. So this is what now is being tested in this question. So when you get to the point where it says your sine A is equal to 2, you need to remember that the graph of sine A can never be 2. And also the period for the graph of sine A is equal to 360 degrees. So keep that in mind because we are going to apply it in a second. So when you get to this point, then because of your knowledge of the sine graph, the mother graph of sine, you then will get here and say this cannot be equal to 2. So this cannot be equal to 2. Why? It cannot be equal to 2 because the absolute value of sine A is equal to 0. Right. So at this point here, we are almost done. We are almost done. At this point, you can just continue with this side of your solution to say that now A will be equal to the arc sine or the inverse function of sine, the arc sine of half, arc sine of half plus, remember this is a general solution, plus K, I'll explain this in a moment, plus K times 360 degrees. Remember I said that the period of the sine graph is 360 degrees. So this is what you'll have, and if you would type this in your calculator, or you would know it since it's part of the special angles, this here arc sine of half would give you 30 degrees. So this would be 30 degrees plus K times 360 degrees. So this here, um, you should remember to mention that K is an element of integers. Positive. So K is an element of integers. This K that you have added here is an element of integers. So another person would probably leave it as I will add this as an O. Probably leave it as A equal to 150 degrees plus K and 360, where K is an element of integers. Guys, I hope you did follow through this question, and please let me know how you found this question. I know it was a bit not well structured, but the most important thing was for you to follow my approach in solving this question. I know some people who understand quicker would have been able to solve this question without even substituting the x um, for sine of A. So yeah, let me know in the comments how you found this question. We have come to the end of the lecture for today, and thank you guys for watching. Please subscribe. Um,